Hi, Year 11. Let's get into Booklet B. We've left school and we're on my coffee table now trying this one. You can see kind of what's in this booklet here. Okay, most of it is non-calculator. Probability trees and conditional probability could come up on the calculator paper instead. In fact, at least one of them probably is more likely to come up in the second paper, if that makes sense. Let's start with Venn diagrams though. I think the thing we've got to look at here is the importance of the word only. Okay, we've got here people sitting on some committees or competing in competitions, singing, dancing and reciting at the Eisteddfod. If we are told these people took part in singing, then they could be here, here or the middle, because all these people take part in singing. If we're told they only take part in singing, then there's only one place they can go. Okay, same for dancing and reciting. Now, where that gets a little bit more tricky is this. If we're told that some people take part in only singing and dancing, they must go there. But if the wording says they take part in singing and dancing, they must be split between here and the middle, because the middle has singing and dancing people as well as reciting. Okay, so it's that only. You can only put the number on if it says only, otherwise you're normally taking things away from it. Now the glory, the beauty of this one is the 0 in the middle. Okay, that probably means we're going to be able to place a lot more numbers on. If there was a number in the middle there, not 0, we'd have a lot more to think about. So let's start. 2 of them only took part in a dancing competition. Okay, we can see them. The word only, we can put them straight on. 5 only took part in a reciting competition. Okay, if they were only in reciting, they can go in there. No one took part in both a reciting and dancing competition. No one took part in both a reciting and dancing competition, so there is nobody in here. Now this is the interesting one. 3 took part in both a singing and a dancing competition. Now, you'd naturally go and put the 3 there. And in this case, you'd be correct. However, you're only correct because there's nobody in there. If there had been, say, one person in the very middle, that 1 would need to be taken away from that 3, because we're looking at all these people now who take part in singing and dancing. There is no sign of the word only there. It says 3 took part in both a singing and dancing competition. However, because there is 0 there, I can put that 3 straight in. 9 took part in a reciting competition. Again, not sight of the word only, so that 9 reciting must be everybody in here. There's 5, 0, 0. Add the 4 there to make those add up to 9. And 22 took part in singing. I've already got 7 within the singing circle. Take that 7 away from 22 and get 15. Again, so be very, very careful of that word only. Now, does it say, is there a part B? There is. What is the probability that the person chosen only took part in a singing competition? Okay, only in bold. So we're looking for the only singers with these 15. Okay, 15 out of, quick tot up, 18, 22, 24. I make that 29. You tell me if I'm wrong. Let's get into the booklet. Okay. 2 other slightly different types of question. This one here, again, sorry. 30 students in Year 11 have decided which subjects they're going to study next year. 21 have decided to study French, 12 have decided to study German, 5 have decided not to study either French or German. Well, let's start with the 5. Okay, now, there's no sight of the word only. Okay, so that's not to say the 21 is going in there and the 12 in there, because some will study both. What is important though, I think, is that there are 30 students, so whatever numbers I put in here, they've got to add up to 30 in total. That includes this 5. Okay, so I'm going to start by taking the 5 off the 30, which leaves me with 25 pupils. If I were to put 21 in there and 12 in there, that would add up to 33, which is 8 more than what I wanted to add up to. Okay, if we can take that 8 off the 33, we'll put those 8 in the middle. Okay, now 21 study French. Let's take that 8 away from that 21, leaving 13 who study only French. and 12 would study German. Let's take the 8 away from those, leaving 4. Let's study only German. And a quick check, 4 add 8 is 12, 12 add 13 is 25, sorry about that, add the 5 is 30, job done. Okay, let's quickly do the part B. Given that a student chosen at random has decided to study French, what is the probability that this student has also decided to study German? No, not the best wording, but the only people who've studied French who've also decided to study German are these 8. Okay, they could have asked that in a much nicer way. 8 out of... that's 30 there, okay. You can see the top 2 have been done for you, so you can pause this at any time and check those. I'm going on to a slightly different type of question now, though, where you're not looking for total numbers of people who are doing something or on committees or doing competitions, but you're putting individual values onto a Venn diagram. Now, there's a couple of things I want to notice, or make you notice. You might be asked to draw something like this, okay, and it's not drawn for you. The kind of main features of this, you start with this, which I'll kind of zoom in. It's almost like a funny E, okay? I won't go into what that means. It means the universal set. It's all the numbers, all the data that is going into this box. Now that is also important. There is a mark for drawing a box around your circles, as well as either 2 or 3 circles, depending how many labels you've got. So if you need to draw one, just make sure you've got all those features. Circles, a box around them, and that funny E, which we won't talk about too much, okay? Now, it says, given the following information, complete the Venn diagram below. So my universal set is 1, 2, 3, 4. So these are the numbers I've got to put onto here, 1 to 12. A is the set of factors of 24, okay? B is the set of multiples of 3, and C is the set of common factors of 30 and 70, so numbers that go into 30 and 70. Now, we could kind of use the lines here for working out. I'm going to go straight on here, no, but don't make a mistake, okay? So let's start with the number 1. 1. Is it a factor of 24? Yes. Is it a multiple of 3? No. Is it a common factor of 30 and 70? Does it go into 30 and 70? Yes. So it belongs in A and C. So I'm going to put the 1 there, okay? 2. 2 is a factor of 24. 2 is not a multiple of 3. 2 is a common factor of 30 and 70. Again, I'm putting 2 in the same place. 3. 3 is a factor of 24. 3 is in the 3 times table. It's a multiple of 3. But it doesn't go into 70, therefore it's not a common factor here. So 3 is there. 4 is a factor of 24. Is not a multiple of 3 and is not a common factor. So 4 only belongs in set A. 5 is not a factor of 24. 5 is not a multiple of 3, but it is a common factor of 30 and 70, so 5 is in set C. 6 is a factor of 24. 6 is a multiple of 3, but it's not a common factor of 30 and 70, so 6 is there. 7 is none of them from what I can see. It's not a factor of 24, not a multiple of 3, and not a common factor because it doesn't go into 30, so 7 is still inside the box, but not inside the circles. 8 is a factor of 24, not a multiple of 3, and not a common factor. So 8, you're in there, set A. 9 is not a factor of 24. It is a multiple of 3, but is not a common factor of 30 and 70, so you're in set B. 10 is a common factor of 30 and 70. It's the only thing it is, so in set C. 11 is none of the above, outside, and 12 is a factor of 24, a multiple of 3, but not a common factor of 30 and 70, so it's there. You notice there's nothing there and nothing there. You can just leave those blank. Okay, that's a little look at Venn diagrams. Let's study some tree diagrams here. Okay, this one quite simple, I think. You just got to put probabilities onto each branch. What are the things I would say? These two here will add it to 1. These two will add it to 1, and these two will add it to 1. However, these two and these two will be identical because the probabilities of drawing a blue ball out of the bag will not change dependent on what happens with the box. They're two kind of separate things. They're not conditional, which we'll come on to later. So the probability of getting a blue from the box is 3/5, meaning not a blue is 2/5. The probability of a blue ball from the bag is 2/9, meaning 7/9 for not a blue ball. Let's take a look at the bottom question. Calculate the probability that neither of the balls drawn is blue. So what am I looking for? I'm looking for the ball from the box not to be blue and the ball from the bag not to be blue. So I'm following this path, okay? Now, if it helps you remember, draw a times line down the middle. Okay, so we're going to do this times this, 2/5 times 7/9. Multiply the top together and multiply the bottom, and unless it tells you differently, you don't need to simplify. Why have I left this one blank? Okay, I didn't like the bottom so much. I filled in the missing values, quite simple. I've actually started working out what the probabilities of all the ends are. So this times this is this, this times this is this, and so on. I quite like doing that because it's a nice check that you've got these right. If you add these all up, 2/20, 3/20, 6/20, 9/20, they should add up to 1 if you've got this right, okay? Let's read part B though. Calculate the probability that Dylan has a dessert or coffee, but not both. Well, if I follow the top line, there, that would be him having both, so that's no good. If I follow this line, that's a dessert without a coffee, that's great. If I follow this line, this is not having a dessert but having a coffee. Again, that fits the brief down here. If I follow the bottom line, that's Dylan having neither thing, and that does not fit the brief. So, if you were to write this out in full, what we've done dessert times not coffee, which is 3/20. You can see it there. We've done not dessert followed by having a coffee, which is 6/20. And you can see that there. And then we add them together and get 9/20. Okay, the next few pages I'm going to let you do yourselves, okay? I'm just going to let you pause the video and check your answers. There's nothing I really want to say about them. Okay, there's one more that I will have a little look at, which is this one, okay? At lunchtime, the probability that Kelly buys a bowl of soup is 0.7. The probability that Kelly buys a sandwich is independent, so it's not a non-conditional one, of buying a bowl of soup. The probability that Kelly buys a bowl of soup and a sandwich is 0.28. That's something that they've started doing to try and trick you out. What they say in there is, the bowl of soup and a sandwich is 0.28. In other words, they have already done the multiplying. They have worked out what this is, 0.28. This times this is 0.28. My workings, you might want to put 0.7 times blank is 0.28. And then you can quite easily see that that number is 0.4. Once you've got that missing number, based on the answer they've given you, it's quite simple to get these adding up to 1, 0.6. and a copy here of what is here. Let's read the bottom bit. Find the probability that Kelly does not buy a bowl of soup and does not buy a sandwich. We're multiplying 0.3 times 0.6, which is 0.18. If I can just pick up on something, okay, where can this multiplying go wrong? It sometimes goes wrong if your numbers are quite low, if your decimals are quite low. For example, 0.2 times 0.3, just to pick it up, okay? So it doesn't apply to this question, but the answer to that would be 0.06. You've got to marry up the decimal places in the question, which are 2 of them there, with the 2 decimal places in the answer. Okay, again, pause, hopefully you can see all that page. And again, a few more for you there. Another example there where the answer has been given to you. The probability that he travels through Ryder and stops for a break is 0.42. So you've got to work out what the blank is.